All right, so welcome back to another week. So let's get started. So before we get started, let's talk about some announcements. So like always, if you're unable to make the discussion, you're always feel free to do your check off in office hours, or if you can't make it to office hours, please let us know via private ed post, and we could arrange something for you. So discussion three assignment was released last Friday, and it's due by this Friday. Discussion four assignment will probably be released on Friday. And we will be releasing our mid-semester project. And this project it's like a mini app. It's basically an app. And so you'll be using all the concepts that you'll be learning from this all the way until next lecture. And it's basically a class planner. So you can create classes or schedules and you can edit things, you could change theme colors. So I think it's a really cool project. And that will give you a lot of experience so that when you and your team are working on your final project, you kind of know how to get started and all that stuff. So yeah. Cool. So here's the agenda for today. So first we're gonna do reviewing, we're gonna be reviewing data flow from last lecture. And then we're gonna also review value versus reference semantics from lecture two, because these two concepts are really important. I really want to make sure that you guys understand these concepts deeply. And the reason for this is because we're going to talk about this framework called observation. And observation allows basically reference types to be able to talk to our SwiftUI views so that whenever things change within that reference type, we're able to observe the changes and update our views. We're going to sidetrack a little bit and just kind of introduce what macros are. You might have seen them in 61A. And then the final or main kind of concept of today is MVVM. And that is a one of the app architectures paradigms that exists in the iOS world. And we're going to see how we could structure an app using MVVM so that things adhere to this principle of separation of responsibility. Cool. So for reviewing data flow, we were presented with this task or this, we want to have some state or we want to keep track of some state within our structs, right? Our views. And first we just said, oh, let's put a normal variable within the struct. And when we try to update this variable, we can see that we have this error. It says left side of the mutating operator is immutable, self is immutable. And that's because structs inherently, we can't change properties within structs themselves. So regular struct properties like this numtaps cannot be mutated within itself. So how do we go by rectifying this issue? Well, we introduce a property wrapper. Again, a property wrapper is simply a wrapper around a property that does additional things. And this property wrapper is called add state. If remember, an add state declares a source of truth. What a source of truth means is that that is the original location of the data itself. So this declares a place where the actual data of numtaps is stored. So we would pre-print this at state property wrapper to your property or variable declarations. Now, what happens is that SwiftUI is going to manage the memory management of numtaps. And whenever numtaps changes or updates, what happens is that SwiftUI will tell this view and ask, do you have any views that require or depend on numtaps? If you do, update yourself accordingly with the new value of numtaps. And it's efficient in the sense that SwiftUI will only re-render the views that depend on numtaps, right? In this case, it won't re-render. Why? Well, because this text of this button doesn't depend on numtaps. Now, if it does depend on numtaps like this, because now we're using string interpolation to embed numtaps into the string, this forms a dependency, right? So when we tap on this button, numtaps will now become 1. And since, again, the button itself depends on numtaps, there forms a dependency. And so SwiftUI will tell this button to re-render itself. So now now button text will be tap me 1. If we do it again, numtaps is 2. SwiftUI tells this View, do you have any dependencies? Yes, we do. Update yourself. And now it's tap me too. Okay. Any questions about at state? Does this make sense? Okay. Again, this is very critical. All right, so now let's talk about the second property wrapper that we learned last lecture, and that's at binding. Now, all the times we write really repetitive code, right? Here in this case, we want to create a reusable component. How do we do that? Well, we create our own custom view. So I encapsulate this shared code, which is the same button that we've seen earlier, and put it in its own struct view. And I called it incrementable button. Now, the issue is I want, or basically I want to have a single num taps, right, located in the content view, and I want to pass it to incrementable button where it can read and also can write back to num taps. Now, in this case, this is an error with this code because we have two at states. Now, when we have two at states, that means that we have two separate locations of num taps, one in content view and one in incrementable button. But we only want one, right? We only want the num taps here. So instead of declaring an at state here, you might also think, okay, why don't we just drop the at state and just do var num taps? Well, that works in the sense that we could read num taps, but we can't write back to it. Okay. So if we want to write back to it, we have to use the at binding, right? So we use the at binding to not only read the value being passed in, but also to write back to the original location, which is here in num taps. So now we have a single source of truth located in content view, and it's being passed to incremental button where it can read the value and also can write back to it. And when we're passing in num taps into incremental button, it's not just a regular num taps. We have to use this dollar sign. So every at state has like a binding, a binding associated to it. So you just pass this binding associated to this at state num taps using this dollar sign. And yeah, so it can read and also write back. So again, properties within our structs can't be changed within themselves. So we use at state to hand over control to SwiftUI so that, excuse me, SwiftUI can manage the memory management and also can, whenever that value updates or changes, SwiftUI can re-render the views to reflect the new value. And it's great for simple properties that belong to a specific view. For example, many apps, right, you have like an edit profile sheet that pops up, right? Or like maybe when you click on a row item in a list, it shows like a detail view, right? That is probably handled by an at state using a Boolean, right? Show sheet is false, right? And I like to use private. So that you do like, for example, at state private var. When you add a private keyword, that means that you're limiting this variable to be only accessible within the surrounding struct or class or whatever, like the surrounding context. So if you do at state private var, what that means is that that variable is only accessible within that struct or pertaining to that enclosing container per se. And again, this declares a source of truth. So that's where the original location of the data is. Now, we could talk about now, okay, so at binding, again, it allows you to read and write from into a source of truth. Sorry, this slide, sorry, I didn't update the slide, sorry. Um, okay. Any questions about data flow? Does that make sense? Okay. What's the difference between at state and at binding and how they work together? All right, let's go back to our lecture 2 and remember about value versus reference semantics. So we introduced how we could, two ways we could create objects within our code. And also how we could, create blueprints to represent data and we create objects from that. So one of them is structs. So structs they conform to value semantics. So what that means is that when we assigned a struct object to another variable, or when we pass a struct into a function, that value gets copied. Okay. So can anyone tell me what these two values will print out for me? So what would Kaylee.occupation print out? Singer, that's correct. And Kaylee2 would be account. And the reason is because again, when we do this, when we do this line right here, we're basically copying Kaylee into Kaylee2. So now there's two instances. Now, with the same exact code, but now we're using a class instead of a struct. Now, what will happen here? They're both the same value, but what would the value be? Yes, account. Very good. And the reason is because when we do Kaylee 2 equals Kaylee, we're not copying anymore. Because classes conform to reference semantics, it creates a reference. And a reference is simply like it just points to whatever the location of this data is. And so Kaylee is right here, and it just basically refers to that data. And so when we do Kaylee2 occupation, well, what is Kaylee2? It's actually Kaylee, right? So we're actually mutating the occupation of here. And so this is a again the same concept but visualized. So again, structs they get copied, and then for classes, it's references. So Kaylee2 references or points to Kaylee, and so both the same count. Okay, so those are two quick reviews again, and these are really important. So just have those ideas in mind. Now let's talk about observation. So observation is a framework by Apple introduced in WWDC 23, which is the release of iOS 17. Now, at state, we've seen at state with structs, right? But the issue is that at state does not work with reference types. Okay. So what does that mean? You can't put an at state in a class. An at state only works within a struct with a view. So what if we want to observe properties like we have done in like numtabs in a struct, but for a class within a class? So for example, this code right here, we have a student, very simple student with a name and major, all right? And it's a class. We have a content view here, and I create a new student. Again, this is a reference type with at state. Now, when I try to click on this button, I will want what this button does is that it changed the student's major to be anthropology. Now, when I do try to click on it, it doesn't update. Okay, it just does not work because a student is a reference type and an at state doesn't work with a reference type. So observation is a framework that basically observes, but also it basically works for reference types. So what it does is that all you need to do is to mark a class as observable. And what it does automatically is that it tracks changes within that object. And it's basically like, if that property updates or changes, you can observe it and do whatever you want. So it basically allows classes its properties to be observed, like an at state on value types. And you create a source of truth using at state. And we'll see an example. So like we talked about dependencies, a view forms a dependency on, in this case, we're talking about observation. So when I talk what this observable data model object means is an instance of a class that is observable. Okay, so you mark a class as observable and you create an instance from it. So a view forms a dependency on an observable data model object when the view's body property reads or depends on a property of that object, right? If it doesn't, that view doesn't track any dependencies. And so if a track property changes, SwiftUI will update the view to reflect the new value. And if there are other properties changes that the body doesn't read, the view is unaffected. It avoids any unnecessary updates. So this means that it's efficient. And I will probably show you what computed properties are. I think this is pretty cool. But basically, computed properties are properties within like a struct or class where its value is derived from other properties within that structure class. And yeah, we'll take a look at an example if I could figure out something on the fly. So there are some subtleties. Um, uh, so you could also share an observable object to other views. So for example, let's say you have a subview and you want that to also also have that observable object. So you could pass it down into that subview, and that subview can modify that observable object as well. And that view forms dependencies if it reads any properties of the object in its body as well. And there's also mechanisms where you could pass through multiple layers of the view hierarchy. So you could pass through subview, 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 subview without intermediate layers forming dependency if they don't read the properties of that observable object. Um, okay, so the next kind of this is, I don't think this is a property wrapper. This is a macro, but there's a thing called at bindable, and it's basically a binding for observable objects. Again, this is a bit confusing, but okay, remember we have at binding. At binding is for value types. This is for reference types, okay? So you're able to have a subview mutate an observable object property using at bindable. And it can exist outside of SwiftUI view. You don't need to be within the SwiftUI view itself. Um, so for example, here, let's say we have a like edit view, right? So here with this at bindable, this book is an observable object. What we could do is that we could pass this book into this book edit view. And within here, we have this text field. And it's sort of, again, it's like a binding, basically. Here in the text field, when I type into this text field, it automatically mutates the title property of this book. So that is with observation. And again, I'll show an example of how we kind of use these concepts together later on. But let's talk about macros. You might have heard this from 61A, but uh, to kind of explain how macros work, um, so we need to first kind of a very high overview of how code actually gets run. Okay, so when you like your programs or when you hit run a compile program, whatever, this is called sort of the workflow. So your code is basically like text to a computer at the start. It just seems like a sequences of characters and it's like gibberish, right? So how does a computer understand your program? So what it does is that it goes through a program called a compiler. And a compiler basically translate that text, that characters into machine code. And what I mean by machine code, it's basically ones and zeros, right? And that's called binary. So your CPU understands ones and zeros. So the compiler's job is to take your English program and translate it into ones and zeros so that the CPU can run those instructions. And there's also another kind of really low level language per se that's dependent on the architecture of your computer. That's called assembly. And that's like the step above binary, which is like the most fundamental rudimentary instructions that your computer can understand. And after the compiler converts that text into machine code, we call that process compiling. So after the compiler has compiled your code into machine code, the operating system, so Windows, your Mac OS, whatever, basically allocates the resources necessary to run your program through a program called the loader. And also there's other processes like before that. And it basically loads your program and runs your program as an executable. So that's kind of the whole process of what happens when you like run programs on your computer, or how code gets actually being, or how code gets run, basically. Now, macros basically are like property wrappers in the sense they add and generate hidden code. So you can create a macro that you could just tack on to something and it will basically add code for you. And the difference is that macros do that generation during compile time. So before the code gets run, but property wrappers happen when the program is running. So an at state and at binding happens when the program is running. but macros they basically inject code before the program gets run. So it adds new code alongside the code that you wrote, um, but it never modifies or deletes your current code. So this at observable, as we see in a minute, is a macro. So when you tack it on to a class, it basically injects code within to your program. So it's very simple. So here is so how do okay, so how does the compiler understand your code, right? So what happens is that in the compiler, it will basically take your code and make sense of it. And how does it make sense of your code? It will basically tokenize or extract features or like, for, in, and it makes sense of that structure and puts it into a tree. And again, for those who hopefully have taken 61A, you probably know what a tree is, right? It's a data structure where you have nodes with subnodes and nodes. So it's like a tree structure. And that tree structure encodes basically the operation of how your code gets run, basically. And with that tree structure, you're able to also do analysis. Say, hey, let's say you have a three right here, and you have a string here, and you have an operator here, like plus. The compiler goes through that and says, hey, you can't add an integer and a string, so it'll give you an error. So here you can see here we have this tree structure that is representation of your code, and a macro just basically inserts nodes into that tree, so that yeah, so the compiler creates a in-memory representation of our source code, and this tree is called an abstract syntax tree. So uh, the the place where it basically expands the macro, we call this expanding the macro, is before the compiler. Usually, a compiler before that has something called a preprocessor, and a preprocessor basically one of its jobs or roles is to expand those macros or to inject the macros into your code. Again, you don't really need to know this, but this is just something I think help understand what macros are. So, for example, here is what you do. So, all you need to do is to make a to, to make a class observable. All you need to do is tack on this at observable to a class, and that's it. And what it's doing behind the scenes is that you can right click on this observable and you can click expand macro. And as you can see here, this is all the code that's being injected into your class automatically. This is Apple's code that injects it so that what it does is that it allows you for books and available book count to be observed. So you could use them within your views and it's basically like an at state, basically. So whenever these property updates, your views can also update as well. So here in this right here, this is what we call a computed property. So this is like a property like books, but what's really cool about it is that its value is derived from books. So let's say in this case, I want to see how many books, I want to have a property, which is an integer, that basically whenever I access it, I want to see how many books are available, the number of books that are available for me to borrow, right? This is like a library manager, right? So its value is books.filter, and a filter takes an closure. And I'm basically saying I want you to filter all books whose is available property is true. And I want to get the count of that. And then return it as an integer as a property. So I could just access this property and it will compute this value on the fly. So that's a very powerful, I think, feature that Swift has. So whenever you want to have a property and you want its property to be derived from values within this class, use a property, use a compute property. It's very powerful. So that is what a macro is. It's basically code that people wrote. In this case, Apple wrote this code, this at observable macro, and you tack it on to something, and it will inject code for you that does a lot of work, right? But to you, all you need to know is it just looks like that, right? All that implementation is hidden away from you. So yeah. Any questions with that? again, don't worry if you don't understand the whole thing. That's just like something for fun or just trying to, what a macro is. Any questions there? Okay, cool. Now let's talk about what NVVM means. What does this acronym mean? So NVVM is one of the many different app architecture models or paradigms that iOS uses and probably Android apps also use. So MMVM stands for Model View View Model, and it's an architectural pattern that facilitates the separation of UI from the backend business logic. So as your app gets very big, right, there's more complex logic that goes into a view. So let's say, for example, right now, again, when I click on that button, it's very simple. It updates a property, it changes or mutates a property. But more complex apps probably does like networking requests. Like, for example, when I click on this button or when this view loads or appears, I want to fetch data from a server. And imagine all that logic crammed into a single view, right? Well, to me as a developer, that isn't the best, especially if you're working with multiple people on a single team. So the separation of responsibility logic, there's also another acronym in programming called SOLID principles. I forgot what it stands for, but one of the ideas is that there's a concept of separation of responsibility. What that means is that a view should only be a view in the sense that a view should only be responsible for UI, nothing else. Right? Why would a view need to know about networking stuff, right? It doesn't need to know about that, right? Why does a view need to know about, fetching stuff from your local disk or storage, right? It doesn't need to know about that. It should only be concerned about displaying UI. So to MVVM allows us to separate that business logic of our code, like networking or getting data from your local storage or doing some other computation out of that view and putting it somewhere else. So the first kind of part of the puzzle is something called model. And we have seen this already. A model is basically your representation of objects within your code. So like a struct person or a struct game player or a struct, I don't know, I guess car, right? So how you represent data in your code using structs and classes, that's a model. That goes into the model kind of umbrella. And then you have your view. We've seen our views, right? That's our Swift UI views. And those are our buttons, our text fields, images, VStacks, all of that stuff. That we've seen those before, right? Now, here we have a new kind of thing called something called a view model. And like the name suggests, it's like a model for your view. I like to call it the manager. Okay. So anything else that's not UI and not your data representation should go into your view model. So, like again, like I mentioned, when you go to Instagram, right? You open the app, it fetches all of that data from its server, right? All of that networking logic should go into your view model. All the stuff that it does when you, for example, follow back someone or you unfollow someone, the UI itself should just be that button itself, and then it calls functions in the view model. And the view model basically handles all of that logic, business logic. So it's very clean, so when you look at a view, it's not like you're not bombarded by like thousands of lines of like UI stuff and the business logic of stuff. So an example of this is like a game. So let's say you're creating like a tic-tac-toe tic-tac-toe game or whatever game you're creating. You want to represent a player. You create a struct player, and that's the model. And then you create your game view where you're actually displaying the UI for that game. And then you create your view model, which is, I like to call my view model as manager. So in this case, you have a game manager. And your game manager basically holds all of the players in your game. It holds the score of your game. It holds what, for example, in tic-tac-toe, what player is at what square, right? It holds the functions when a player clicks on a square and it computes, oh, did the player win or not? And all of that stuff. It handles turn taking, right? Is it the current player's turn or is it the other player's turn? So all of these properties, right, are in the game manager. And the game manager is a class, okay? So your view model should be a class. Why can anyone give me probably a reason why a game manager should be a class and not a struct? Why should the view model be a class, not a struct? Yes, exactly. So the answer uh so the answer was because we're going to be referring to it a lot. We're going to be using or accessing this game manager in a lot of our subviews. And when we pass around this game manager, if it was a struct, it gets copied, right? So we don't want to create a copy and give it to our subviews because when that happens, then that subview has a out of sync state with other views, right? Maybe when we create a copy to a subview, what if the score changes here, but then the score doesn't change here, right? So a class, we create only a single instance, one object, and we basically pass references down into our subviews. So our subviews can reference this class. There's only one instance of this game manager being at all times. Okay, does that make sense? Now, we want to observe properties on this game manager. For example, let's say I want to know what round this game is. Like, are we round 10? Like, are we just started, right? And that's probably like a number. Now, when this round number changes, I want my game view, like probably there's a label here that says round zero, round one, right? So when that round number in my game manager changes, I want the game view to update and reflect the new value of this game round. Now, remember, we can't use an at state on a reference type on game manager. So to make the properties within game manager be observable, we tack on this at observable onto our game manager. Okay. And that allows all of the properties within game manager so that whenever those properties change, game view is able to update those values. Does that make sense? Okay. So your view model should be a class, a reference type, and it also should be observable. How do you make a class observable? You tack on that at observable macro onto that class. And everything of its properties are now can be observed by your views. Does this sort of make sense? Okay. Okay. So how do we convert, and like for example, an existing project into MVVM? So your models, you don't need to touch your models, right? Your models will be the same. You need to move all of your business logic, if you have any, from your views into this view model, which is again, I like to think of it as like a manager. All of your add state variables in your views should be only be pertinent and or what that means is that only be relevant to the views themselves. For example, your view, for example, like I mentioned, like the editing view. Let's say you want to show like in your game a player edit view, or you want to show like a settings view, like a game settings view. Showing that sheet should be an at state that should be private. And it's like a Boolean, right? Show this sheet, dismiss this sheet. We haven't learned about sheets, but we'll talk about that next lecture. But all of the at state stuff should be only logic pertaining to that view itself, right? Nothing else. Like I mentioned before, your view model should be a class so that we could pass a reference to our subviews rather than copies. So how do we share model data, or like how do we share data to our subviews? So one of them, I think we've seen before, is to pass that object directly into the view hierarchy. So basically, the subview has a parameter that accepts that, and you just pass it in as an argument. Now, this is really convenient if you have a shallow view hierarchy. What that means is that you only have like three subviews, or like like just like not too deep. But if you have a view that has like 10 different subviews, right? And how do we if you physically pass that data one subview, one subview, one subview, one subview, it's just kind of messy. So we could do something by passing that object into the view's environment. So what is a view's environment? An environment allows SwiftUI to pass system-wide settings to views. So every single view has an environment. And by default, you can get access to like, oh, whether the app is in dark mode or light mode, or whether what orientation is your app in, those kind of things. And views inherent environment from its parent view, unless you want to override any values using the @environment modifier. So by default, when you create a subview, that subview's environment is inherits all of its parent view's environment. And if you want to override that, you could on that subview, you could do dot environment and you could pass in a observable object, and it overrides the one in the parent. So this is very convenient because you can pass it again, you can pass this observable object into a subview's environment, and all of its subviews inherit that. So you can just basically get it from each subview without having to physically pass it from one to the other. All right, so I think I'll just show you an example of MMVM. Um, Again, I'm just gonna go on this on the fly. So this is one of our last semester's like one of our discussions, and this is called Bartology. Okay, and this app basically does networking requests, and it simply fetches all of like the BART stations here. And I can click on a BART station and it gives me like a map of that BART station and like that description of that city or whatever. So here's Concord, I wonder if I could let's see here. And again, I'm clicking option to do a two-finger pan. Here is Berkeley, right? So that's this app. And what it's doing is that it's basically fetching or making network requests. Like we haven't learned that yet, but it's doing all that network. It's calling the BART API and fetching all of that data. And here you can see I have this BART models file. And again, it looks very complicated, but it's just I fetch all of the data from the API and I'm basically changing it into our structs. Um, so you can see here a BART station has a name, it has an address, has a county, has a state, and so forth. Okay. And again, don't worry all of this. It's just basically converting it into our structs, right? Our classes, whatever. Um, so here within this content view, again, this content view is just basically what the UI you see here. It has private at states pertaining to the camera position of MapKit. Again, we're using MapKit, which allows us to display this map here. And it has an optional selected station so that when I select a station, I can basically show that detail view. And here I have a list of stations, and these are just a list of BART stations, right? Now here is where we actually doing the fetching. Again, you don't need to understand this. Just think of this function. You don't need to understand every single line. Just think of this function as we're fetching the stations from this API. All right, that's all you need to know. So here is where we're basically getting all of the BART stations, right? And it's within this content view. And here in our station detail view, we have a binding to that selected station. So then when I click on it, it's able to also read the value, right? Um, and here we're also fetching the data, the detail view data for that station itself. And yeah, so that's basically it. So how do we convert this into MVVM? So what we do is that I like to create a new view model. So what we do is you do import observation. So observation is a framework, you have to import it. And I create a class. Okay, so I'm gonna call this I'm gonna call this my BART station manager. Okay, so this is my class, and again, this is gonna manage. It's gonna hold the logic of fetching the stations for me. So I need to make this class an app observable. Um, And the reason is because I want to have a variable here, a property, that holds all of my stations. So what I'm gonna do is I'm gonna go to my content view, and you see how I have this stations right here, right? This content view, this view does not need to know about the stations. Its only sole purpose is to display the UI. So I'm gonna move this out of here, and I'm gonna put it to my view model. Okay, so I'm gonna plop it down here. Now we can't use an add state here. An add state only works with it only works with views, right? So I'm gonna delete that. I'm gonna make this public so that I can access it in my views. So we have a empty array of my BART stations. Cool. So now let's go back to my content view. And as you can see, stations here, we can't, that's not my view model. So we'll work about that later on. So now we see we have our fetch stations, right? We should bring that out and put it into our view model. So I'm going to create this, put that function there. Nice. I need to also import Foundation. Foundation is simply a library that contains all like Swift things like URL. Again, don't worry about the logic here. All you need to know is that this function fetches our stations. That's all you need to know. Okay, so we have a function here. Now let's actually fetch the station itself, right? So how are we doing the fetching? We're doing it actually here. So in SwiftUI, we have this view modifier called onAppear. So when this view appears, you can do something. And in this case, we're fetching the stations. Again, don't worry about what a task is. Just know that we're just calling this fetch function, or fetch stations function. Okay, that's all you need to know. So there's also a onDisappear for those who are interested, but we could remove that. And on our view model, we could, when we create our BART station manager, we could run fetch stations. So how do we do that? So whenever we want to do something, when we create an instance, we use the initializer. So we don't need to take in a stations. We just basically call fetch stations. So what this code does is that it will call fetch stations and fetch all the stations and populate it in stations here. It's going to populate it into this array. So cool. So that's basically, I think that's what my view model is. Now, of course, we want whenever station updates or mutates, I want content view to be able to observe this property and refresh its view to reflect the newly fetched stations. So how do we make the stations observable to a view? Well, since we imported observation, we could use this observable macro. So we tack it on to this class, and I could right click and I could say expand macro. And as you can see, it injects all of this stuff into this code, which allows for us to observe stations in our views. Okay, we don't care about any of this. Let's just hide macro expansion. Cool. So let's actually create an instance of BART Station Manager. So let's go back to content view, and I am going to create um, we're going to create our instance here. So I'm going to do state private var view model, and I'm going to create the instance here, BART Station Manager, like so. So now, instead of stations, right, we brought stations into view manager. So we just do view model dot stations. Okay. Now, here in station detail view, let's see. Okay, cool. Nice. Okay. So let's say I want, for example, maybe I want station detail view to have access to this view model. Okay. How do we do that? Well, one way is to basically physically pass that object into station detail view. So like this, I can do var view model BART station manager. And then here in station detail view, you physically pass it in. Uh, right, like so. You do view model. Like so we're passing view model into station detail view. And so if station detail view needs to use view model, we could access it here like so. Another way is via its environment. So let's say pretend station detail view has a lot of subviews, right? And you want like the bottom subview to have access to view model. What we could do is that we could basically, delete this and inject the object into station detail view's environment. So we could do this by using the environment view modifier and passing that observable object, this view model. So we're injecting this view model into the station detail view's environment. So now station detail view can get access to it from its environment. So how do we do that? We use this at environment, and then we provide a key path, like a property. In this case, we supply the type of the object, which is station, BART station, BART station manager dot self. Dot self is the type. So we're basically saying I want to get the observable object whose type is BART station manager from your environment, please. And then we basically can get it here, like so. And there it is. So now we can get access to view model within the station detail view. Now pretend station detail view, right, has another subview here, called I don't know, station station detail view, right? Now in station detail view, it has access to the view model because station detail view inherits the environment of station detail view, which already includes this view model. So again, let's just uh station detail view, right? I could just basically copy and paste this line right here, and then just paste it into here. Because I have access to this view model in station detail view's environment. Okay. So you can think of, if station detail view has another subview, I could also have access to this view model because it's being injected into its environment and every subview inherits it. So that's a quick look at how two ways you could pass data. One, by physically passing it as an argument. The second one is injecting it into the view's environment, in which its subviews have access to it because subviews inherit its parent view's environment. Okay. Technically also we should move selected station into the view model. But since we're running out of time, we'll just stop that there. But hopefully you could see how we could use at observable and MMVM together, right? Your view model should be a class, it should be observable class. You create it in your root view, and you can basically pass it into your subviews, and your subviews can access it. All right. Does that sort of make sense a little bit? Okay, cool. All right, now let's go to our Kahoot. Hopefully I fixed it. If not, yeah, so far you guys have been getting attendance for free this whole semester. Um, I think I fixed it. So yeah. All right. Does anyone need more time? Good. Okay. So the question is, which one is, I think, the correct one? So which one is true of the four? So MVVM has four different components. At state is a macro. When we create a view model, it should be observable. A view model should be a struct instead of a class. So which one is true? Okay, there's three false, one true. Okay. And what I mean by four components, it's like there's four different things. Okay, so each letter has its own like thing, right? Okay. Does anyone need more time? Very good. Okay. So so the correct answer is when we create a view model, it should be observable. Okay. MVVM has three components: model, view, view model. Okay, the view model is a single thing. An at state is a property wrapper. Okay, it's not a macro because an at state is something that needs to be done during runtime when the program is running. A view model should be a struct instead of class. No, the view model should be a class. So a view model is a class and it's observable. Okay. So hopefully any questions about this? Does this sort of make sense now? Okay, view model. Okay, first thing you think of view model, it's a class. It's observable. Okay, cool. With that, that's about it. So,
Just making a note for people who did, so people who didn't come to discussion, just to let you know, we have a network sheet for people who are